Hello and welcome back to Calculus 1, section 4.4 on graphing functions. So this is a survey section. We do not learn anything new. We take a whole bunch of old concepts, mix them all together, and we use those to graph a function. Something like x times ln squared x minus 1, or 3 divided by x squared plus 3 minus root x, or something, right? So stuff that is not basic functions which you can graph just by shifting left, right, and so on. Now, before we do any of the examples, we're just going to write the list, call it a shopping list, right, of all of these mathematical concepts which span from algebra into calculus. There will be up to or more than 13 separate calculations that you can do, resulting in some of these problems to take anywhere to like 30-40 minutes to crank, because you will be going through not just first and second derivative tests, but technically asymptote calculations and all the other stuff. So let's take a look at the list. So we start with number 1, domain and range. I'll put this and range in parentheses because in 99% of the time, you just don't care about the range, but it's something that, you know, you could get. Number 2, X and Y intercepts. Someone's microwaves. We have X and Y intercept concept from algebra, where the function cuts through either x-axis for x-intercept and y-axis for y-intercept, and you find those when you set either x or y to 0, depending which one you're looking for. So for x-intercept, you set y to 0. For y-intercept, you set x equal to 0. Number 3 will be all 3 asymptote types. So we have vertical asymptote, horizontal asymptote, slant asymptote. Knowing that slant asymptote only happens in one type of the function in one case, and that is rational function when you divide two polynomials, where the degree of the polynomial in the numerator is by 1 larger than the degree of the polynomial in the denominator. That's the only case when you have slant asymptote. All other cases, no slant asymptote. And horizontal asymptote and slant asymptote cannot be in the same problem. So if you have horizontal, automatically you can't have slant. If you have slant, then no horizontal. Vertical asymptote has its own section when we did limits. And sometimes if you have issues with figuring out whether the asymptote is there or not there, you can always use those limit procedures from 2.4 and 2.5 to figure out what asymptote you have. Number 4, calculating first and second derivative, because you will need those for number 5, first derivative test, and then number 6, second derivative test. Now these tests are the ones that we covered last class. And for the first derivative test, you know that it will give you increase, decrease, min, max. And the second derivative test will give you concavity or inflection points. Now, for number 7, I'm going to put something that pretty much no one ever uses, but it could be useful. Symmetry. For number 8, we are going to put additional points. And that's only if you don't have enough information from the previous stuff, right? Previous bullet points. And we'll put at number 9, graph, which is you drawing the graph. Now you said, hold on, you said 13. Yeah, I did, but then 3 asymptotes crammed into same bullet points. That those are all separate calculations. First and second derivative, right, mushed into the same one. And you have the X and Y intercept. So you do have 13, at least 13 different calculations you can do to come up with a graph. As you can see on this list, there's nothing new. You all know these from either algebra or pre-calculus or calculus, where we discussed the derivatives and derivative tests. Symmetries, then the pre-calculus, and then additional points, that's middle school, right? You say, I want to calculate the point when x is equal to 2, just plug it in a function, right? So all we are going to do is we get a problem and we work out all of these calculations, and then we plot the points, then we plot the asymptotes, and then we fill in with the rest, whichever way the line must go. So you will never, right? You will never have a situation where you, well, I mean, you can always not know what to do, but you will always have enough information to clearly proceed to graph. And if really something, terrible is happening, you can always compute additional points and deal with it that way. As I said, these problems, since there are a lot of calculations before you start graphing, right? So we warm up our wrists because these problems are excellent for killing time and carpal tunnel, right? It's like things like this. So you might want to do that. You want to make sure fingers. And then this is another one. It's really good to stretch your, right? And then let's go and do some problems. So we'll start with something that we could graph without the sledgehammer, but we're going to use sledgehammer because we can. So let's say f of x is equal to 6 over x plus 2 minus 1. You know that this function shifts 2 units to the left, shifts 1 unit down. It's 1 over x as a basic graph. You can draw this graph fairly precisely without doing any of this work. But and why simple if we can complicate things? So let's go. I know. Number 1, domain. We see that there is a single value that would make this explode, and that is at -2. So negative infinity to -2, union -2 to positive infinity. That would be our domain. This is literally your first lesson of pre-calc 1, right? Now we're going back to algebra. We're going to calculate X-intercept by setting y equal to 0. So we are calculating 6 over x plus 2 minus 1 equals to 0. That's 6x plus 2 equals to 1. Cross multiply, we get 6 equals x plus 2. And finally, x equals to 4. I am going to... Hey, that's my job. Shh, I don't want to... So now you are going to box x equals 4 because that is... sorry, not x equals 4. You're right. See, that's what you... When you go behind the back. 4, 0 is a point, which is the x-intercept, and that point will be placed on the graph, right? So we want to box all of these things that will directly go on a graph so we can quickly find them. Sometimes you'll have 2 pages of calculation looking at some of the derivatives coming up. The second part of number 2 is to find the y-intercept, and y-intercept is going to have, when you set x equal to 0, it's going to have 6 divided by 0 plus 2 minus 1, which is 3 minus 1, which is 2. That gives us 0, 2 as a point, and we are going to box that as well. So far, we have the X-intercept and we have the Y-intercept. Number 3 has 3 different asymptotes. Well, we already know that the vertical asymptote is at x equals, very good, because the domain is interrupted at -2. That's where the vertical asymptote is. Now we would also like to find horizontal asymptote, and if you are not sure how to find the horizontal asymptote, you will have to do the limit as x goes to infinity for the function 6 over x plus 2 minus 1. And when you solve this limit, you would see that the first part here, because you're dividing 6 by infinity, first part is going to 0, so the asymptote is at y equals -1. So in some cases, for vertical asymptotes, you really don't have to do the limit. In some instances, you will have to do the limit. Now, for horizontal asymptote, it's just the fastest to just do the limit and be done. Slant asymptote is none, because it is mutually exclusive with the horizontal asymptote. If you have one, you can't have the other. The next step is to calculate the first and second derivative, and that would be, now when we take the derivative here, the fastest way obviously would be to rewrite this function as 6 times x plus 2 to the -1 minus 1, and then take the derivative from there. So that would be -6 x plus 2, and then subtract 1, right? And then as a chain rule, which is the derivative of the inside, is just 1. So now to simplify this, you will write it as a -6 divided by x plus 2 squared. And that's your first derivative. Now for the second derivative, you don't want to look here. No, don't look at it there, right? Don't look at it. You already have a beautiful set over there to find the second derivative. So we are going to say -6 times -2 is +12. We still have x plus 2 to the -3 now, and the derivative of the inside is 1, giving us 12 divided by x plus 2 cubed. So now we have our derivatives. These derivatives, I'm not going to circle them red because I don't get to graph those. I get to use them now for number 5, first derivative test, which will give us increase, decrease, and mean and max. So for the first derivative test, we know we need critical points. So we set the derivative equal to 0. We cross multiply, and we find that -6 equals 0, which is not. So no crit points. No crit points means no min or max, because min and max must occur at critical points. Since we did not have any critical points, we can't have min and max in this problem, which is okay because we know what the graph looks like already, and we know it doesn't have any min and max. Now, to do the first derivative test, we partition. Remember that partitioning is done through the critical points for the first derivative, critical points and asymptotes. we do have an asymptote at x equals -2, and our domain are infinities, so we'll have to pick two test points, say -4 and 0. So now we compute the first derivative at -4, and we have -6 divided by -4 plus 2 squared. Now I understand that you can compute this, but in many cases we don't care what the numbers are. We just care if those numbers are positive or negative. So the numerator is negative because of -6, and the denominator is always positive because of a square. When you divide negative by positive, you get negative, and that means that you have a decrease, right? So f of x is going to decrease on that one. Now we're going to repeat the whole procedure for 0.
F of x or prime of x?
F of x is decreasing if the prime is negative. That's the derivative tells us what the original function is doing. Again, we have a -6 divided by a positive number because denominator is squared. We still have negative divided by a positive, which is a negative, and we still have a decrease. Great. All of that fell into place exactly where we needed to be. The next part is part 6. By the way, this is the important piece of information for graphing. You visually see that the function is always decreasing. So when you draw the pieces of a line at the end, you make sure those pieces decrease. All right, so now the next step is to set second derivative equal to 0. When you cross multiply, you get 12 not equal to 0. No inflection points. So we have no inflection points. But if you remember from last class, 2 days ago, we said that you partition over inflection points and vertical asymptotes. We have no inflection points, but we do have a vertical asymptote at -2. Domain is still negative infinity to positive infinity. So pick the two test points. We can go with the same test points of -4 and 0. You can pick anything you want other than -2 in each of the regions. And to find our second derivative of -4, we have to go, say, 12 divided by -4 plus 2 cubed. Now, guys, cube is tricky because it preserves the sign inside the parenthesis. The sign inside the parenthesis is negative this time because you have -4 plus 2, that's -2. So this will be positive divided by a negative, which is negative, meaning function is concave down. So negative second derivative gives us concave down. Then we do the same calculation for 0 in the second derivative, which is now 12 divided by 0 plus 2 cubed. Again, cube preserves the sign, so now we are dividing positive by positive, and we are going to get a positive. So f of x is concave up. Now we have enough information. We don't need anything else. Let's try and graph it. And then if we really need something, we'll go on. Now, it's important to draw big. That's the first rule of engineering. Draw big. Your technical drawings are your life. Specification sheet and so on. So we're going to start with the Come on, there we go. I've been practicing these straight lines to get them perfect every time.
Oh, yeah, yeah. You can use the shapes and you can draw it.
Yes.
Yeah.
This is what shapes give. Look at that. They are modeled by...
By your drawing?
Yes. What do I have? We go all the way up. We see that we have 4, 0, and 0, 2. Four, 0, 0, 2. Those are our intercepts. We also know that we have a -2 for the vertical asymptote. Usually I like to use red for the vertical asymptote because vertical asymptotes cannot be pierced, crossed at any point. And I use blue for horizontal asymptotes because they can be pierced locally. Blue is less threatening than red, right? So I'll put the blue there. So now I have my -2, -1. I have the asymptotes, and the functions have to follow these asymptotes going to infinity. So when I look at the part where I have 2 points already given, it shouldn't be strange, right, to you to just connect these points and follow the asymptote. That's all it is. You have to follow the asymptotes. You have to go through these points. So there you go. Now you check if this shape of the line fits the description for the right side for the first and second derivative test. So the right side says it's concave up. Well, that's definitely concave up. Concave up piece is the one that might looks like that. So it's a concave up piece. And also from the first derivative we see that it's supposed to be decreasing. So we have a decreasing concave up part. Awesome. Now in the next on the other side we have a choice of having this one or that one. So one of these I get to keep and the other one I get to delete. These are the only two options that you can have because you has to follow, the function has to follow the asymptotes as they go to infinity, and there is no other way to draw anything here other than this. Now, which one do we get to keep? Which one do we get to throw away?
Keep the bottom.
Why?
Because it's decreasing.
Because it's decreasing. Excellent. Keep the bottom because it's decreasing, and you also added, right, Nick? You said that concave down. So if you look at the left part of your first and second derivative test, you will find concave down, you will find decreasing. And that is the bottom line. So bottom line, we keep. Top line, we get to throw away. Can anyone give me a reason other than elimination, right? Why the top line cannot be the answer? Yes.
Something with the domain.
No, it's in the domain still, from a negative infinity to -2.
Because it's 1 over x. So since the top number is positive and the bottom number is negative, then the outcome will be negative, which is below.
Okay, that makes sense. Sure.
We don't have an X-Intercept in that.
That's the one I was looking for. Do you see that the upper pink line cuts through X-Intercept, and we did not detect that X-Intercept in our calculation? The only X-Intercept we found was at 4. and it's there, and it's used up. Over here, there would have to be another X-intercept that calculations would have to spit out in order for the pink line to be the answer. So we have to get rid of the top pink line for multiple reasons, right? One of them is process of elimination because the bottom line is the correct one. Also, no extra X-intercept, and what you analyze with dividing the numbers, that also works as well. So now I'm going to just put in the black line over here for graph, right, to match this, and ta-da, there it is. All right, so guys, this is what the cheapest possible problem you can get looks like. I already heard the word exam. Your exam questions for this will be broken into parts, so you do not have a 30 or 40 minute problem, which if you mess up on a step number 2, everything else is wrong. On your exam, you will have first derivative test, and you will just have to write the answer like we had in class. Then you will have a separate problem, different function, second derivative test. And then you will have the third problem where all of the calculations are already done for you. You will have to look at the information provided and just draw the graph. So this will be broken, and there will be a special problem for min and max and that kind of stuff. So all of these calculations that you see here, they will be broken over a couple of problems, so that, you know, the mistake that you might make, you know, early on doesn't propagate, destroying a whole question that's maybe like 40, 50 points, right? Because if you have a problem it's going to take you 40 minutes, it better be half of the exam grade, right? If your exam is 80 minutes. So it makes sense. All right. Now, let's say you care, right?
First assumption, wrong assumption.
Yeah. And you want to check your answer. All you need to do is to go to Desmos and graph the function and make sure that it matches what you drew. That's it. Now the key is not to do it beforehand, because you will not be practicing fitting the curves right from the information. So you check after you are done graphing to develop the skill. Like everything else in life, this section is a skill. And the only skill for this section, right, don't worry about the old calculations, you should know that, right, is to take the information, all the points, all the asymptotes, all of these relations between increase, decrease, and so on, and put those in terms of lines. And then when you're done, you go to the graphing utility, whatever you like, and you say 6 divided by x plus 2 minus 1. And the first thing you will notice, X-intercept at 4, Y-intercept at 2. You see the intercept, you see the asymptote at 2, negative 2, sorry. You see the horizontal asymptote at negative 1. So all of the features that we calculated, you can see there on the graph. And then you move to the next problem, right? Let me consult my book for the problem.
I like the upside down cross.
That's pretty much.
Yeah, no, it was. I didn't notice that it was the wrong book. I have them all on the shelf, one next to the other. I just pulled this one quickly. All right. So,
That's great.
Book of Revelation, page 278. X squared divided by x minus 2. You are supposed to go through 13 different calculations or whatever amount, right? So start from domain. What is the domain of this? Everything except 2. Awesome.
Father,
Yes.
your admin says to do Minecraft zone.
Okay. No.
No?
Why not? What did the other one say now?
She hasn't replied yet.
Are you not the sheep?
You just assume it is a sheep.
I can assume whatever gender I want.
Yeah.
The rosary beads?
Yeah, the rosary beads.
Can we go through fast and do all of it?
Each bead is
I said because that
It was so much calmer than usual.
You have a presence.
his voice is vocal.
He speaks in tongues.
Yes. No, that's it. I have here that is not defined, so it doesn't exist, right? Otherwise, that's your tool.
Oh my goodness. You're disgusting.
I'm not disgusting. Catholic Church.
That is embarrassing.
Probably
So
something.
the expert, could you get plus or minus? One, just you multiply, you cross multiply, would be 0. Okay, cross multiply, there you go. Minus 2 crosses out 0. No, but you multiply by 0. Exponential by 0. Would be 0. You multiply by x and on both sides.
So domain, x, y, intercept. Vertical, horizontal, slant, asymptote. Number 4, first and second derivatives.
Y-Intercept is 2. Yep.
These problems are a lot of fun, right? You can feel the burn over here, right?
She says that she doesn't have. She says you have the stuff to run it full time, and
Yes.
she's not doing.
Try service.
Are you going to do it then? I would play. David would play.
I don't have that many friends, so I need friends. I have an account. I'll do the house.
Good job.
I'll make a microphone.
Mushroom.
That's my only job, microphone. There's no other mushrooms.
I'll make it.
And then start selling it.
I'll be efficient.
We need to cover our basic necessities. So who's going to be the weed farmer? Oh, yeah, we got one. We need to get the seeds.
I'm going to kind of go on the can't factor in binary. So you divide by x squared. Right? So this would be 0.
Yes.
Over 1 over x.
Putting your finger in the jar on the
Divide all 3 by x squared.
Yes, I know it is.
When you simplify, you get 1
What?
over
Oh no. Is that a witch?
Wonderful.
Well, there was one on the quiz today.
That's a lot of, for example,
There was one on the quiz today, the last one.
Are we gonna have communion in there?
Oh, I don't know.
Yeah. When are we having communion?
Father, when are we having communion?
So, I believe
Are we
it
gonna
was
have communion in here?
there was
Always a
one
game.
that no,
The fuel, right?
this one.
It has
Yeah.
it's straight
This
coming
one,
in.
I got the right answer, but they kept the Y raised, so I guess, like that is wrong. But the same answer was the same, all the same, just like they kept the Y and the same.
yeah.
Can we now start calling God Sky Chinese? Can we make that a thing? Oh, it's like, oh my God,
Number 1 domain is going to be from negative infinity to 2 union 2 to infinity. Then we have X-Intercept. We set y equal to 0, so it's x squared x minus 2 equal to 0, where x squared is equal to 0, x equals 0, so we get 0, 0. And now that's at the same time x and y intercept, so both. Number 3, vertical asymptote, we already have x equals 2 because it interrupts the domain. Horizontal asymptote is limit x goes to infinity of x squared divided by x minus 2.
So who won the costume contest?
Me.
You came second.
Wait. You didn't even know what mine was.
I can see.
Oh, because it was so hot.
Too bad.
Yeah, you have to wear the entire
Oh, you gotta be kidding me.
Yeah, I'm sweating. So
I'm sweating.
Is this just so I can get the extra credit? Do I have to wear it just?
it was a lie. Like a cake.
What, are you serious? No, damn it, I'm gonna change. Fuck this. I'm gonna change. I've been sweating my ass off here. Literally, my legs have been stuck in this.
Wait, oh, you have the full costume?
Yeah, I'm wearing a romper right now.
Yeah, you'll have to model that for everyone.
I'm not modeling.
And then you'll lose your points.
Well, you don't know if that exists or not now.
We have a rational function where the polynomials, right, with the quotient of two polynomials, plus 5, and we have the degree in the numerator to be by 1 larger than degree in the denominator, which means that we definitely have a slant asymptote, which means that we definitely cannot have a horizontal asymptote. But let's say you just want to actually do this limit. You will divide everywhere by highest degree, which is x squared. This skill is in 2.5. That skill is in 2.5. So you will have to brush up on that. And we have 1 divided by 1 over x minus 2 over x squared. Both of these go to 0 when you divide by infinity, and you get 1 divided by 0, so does not exist because you're dividing by 0. So horizontal asymptote does not exist. Slant asymptote, yes. And how do we get this? Long division, beautiful. That's x minus 2 divided into x squared. It goes x times. When you multiply back, you get x squared minus 2x, and then you subtract. These guys cancel. You get the 2x. No. And then x goes into 2x plus 2 times. And there's your slant asymptote. Y equal x plus 2. Long division of polynomials to get this particular value. So now, in number 4, we are going to find first and second derivative. We can use quotient rule. You can use logarithmic, whatever makes you happy. That's what the goal of math is, right? Happiness is our primary concern. X squared times 1. So this simplifies into 2x squared minus 4x minus x squared divided by x minus 2 yeah, hide that. X squared minus 4x. So this would be our first derivative. Do what?
You did in 3 steps. I have like half a page.
Yeah, but I also have about 15 years head start, so there's that part, right? I have no doubts that you would be even better than me, but years have to unfold in between, right? And now we have another one of these, which we can either deal with logarithmic differentiation if you don't want to bother yourself with quotients and chains and stuff. So whatever, right? So obviously logarithmic x squared minus, because I can just write it out, I don't have to bother with the derivative. In the parenthesis over here, we have the top function, which would have the x squared minus 4x with 2x minus 4 on top, and then minus 2 times x minus 2, and then a 1, so that 2 can go up there. And yep, that's it. So we're done. Those are the derivatives. And I can simplify the second derivative a little bit. I factor out 2 and I factor out x, so there will be a 2x over here. The next one is, since I kicked x out, I have x minus 4 divided by x minus 2 squared times the parenthesis of x minus 2 divided by x minus 4 minus 1 over x minus 2. It's easier for when we need to set it equal to 0. Number 5, first derivative test. We have our first derivative, and we set that equal to 0 of x minus 2 squared equal to... by the way, do we still remember what the problem looked like? Yeah, okay, just want to make sure that we are all on the same page over here. All right, so we go down and set is equal to 0. We cross multiply, we get x squared minus 4x equal to 0. Kick out x to get x minus 4. And then x is 0 and x is 4. These are your critical numbers. We need to find y values, and these will become a min or a max eventually, right? So we need to find y values for these. So y is equal to f of 0. So we have 0 squared divided by 0 minus 2, so that's a 0. And we have our first 0, 0. Now that's either a min or a max, but it is definitely a point for the graph. I'm going to box it. I'll write later next to it min or max. Right now I am boxing it because it definitely goes on the graph. Y equals f of 4. I'm using original function because I'm looking for the y value, right? So original function, so that's going to be 4 squared divided by 4 minus 2. This is 16 over 2 equals to 8. So we have 4, 8. Again, this is either a min or a max. I just know right now that it's a point which I will be eventually graphing. Awesome. The next step for us is to do what? We need to do, we haven't done any partitions yet. We didn't do the first derivative yet, test. We only found critical points. Now I have to do partitions, and partitions are done at critical numbers and the asymptote. So we have 3 values to worry about. Vertical asymptote was at 2. I did not box this. Oops. We will be graphing the asymptote. So we have 0, 2, and 4 for our partitions. 0, 2, and 4 from negative infinity to positive infinity. This gives me negative 1, 1, 3, and 5 as test points. And now I have to do 4 calculations for the first derivative test to figure out the increase decrease, which will ultimately give me min and max. F prime at negative 1. F prime at negative 1. Where's my F prime? Oh, holy nightmare. That's -1 squared minus 4 times -1 divided by -1 minus 2 everything squared. Yep. Equals to 2 plus 4 divided by something positive. It's squared in denominator, right? So I have positive number divided by a positive number gives me a positive number. We have an increase on a -1. F prime at 1. 1 squared minus 4 times 1 divided by something positive because it's squared. I have 1 minus 4 divided by a positive, all together equal a negative decrease. And what do we get for free? Minimum at 0, 0. Very good. So this, no minimum, maximum. So max, it's a max at 0, 0. Now f prime at 3. 3 squared minus 4 times 3 divided by something positive, which is 9 minus 12 divided by a positive value, also negative. Boom. F prime at 5. 5 squared minus 4 times 5 divided by a positive number is equal to 25 minus 20 divided by positive. Positive divided by positive is positive. And we have increase. What we get for free is that at 4 we have a minimum. All we need to do now is to calculate second derivative test, and then we will attempt the graph without doing anything else. So 6, it's the second derivative graph. Now this is right a little bit long, so you select it like this, and then you copy it. There we go. Because you need to set that equation equal to 0 and solve it. Come on. Now, this looks terrifying. For a split second or for an untrained noob. What I see here are 3 joke equations. Every time, which is why we said factor, 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 right? Each factor is a separate problem. Each one. And these denominators, when you cross multiply, they all die. So these are very simple equations. (2x equals 0), x equals 0, x minus 4 over x minus 2 squared, this won't erase over here, equals 0, x equals 4. We are already done with these. We know that these are not inflection points because we already have min and max for them, right? The only one we are focusing is the big one. X minus 2 divided by x minus 4 equals to 1 over x minus 2. That's the only one we are focusing on. If you set it equal to 0 and then you move the term to the other side, right? So cross multiply, we get x minus 2 squared is equal to x squared minus 4x. Square, so these are separate equations, right? Square the left side, you get x squared minus 4x plus 4 equals to x squared minus 4x. Guys, this is where your grade dies, usually. You forget the middle term. Don't. Good. So now move everything to the left, and you just have 4 equal to 0. Well, no solution. No inflection points. Great. We are partitioning only on the vertical asymptote because we have no inflection points to partition at. Pick 0 and 4 and run your second derivative test, which is this whole mess here. Oh yeah, we have to keep away from 0 and 4. 1 and 3. Red. So what do we have? We have 2 times 1, 1 minus 4 over something positive, and then we have 1 minus 2 over 1 times 1 minus 4 minus 1 over 1 minus 2. So I have a positive number times a negative number times, over here I have a negative divided by a negative, which is, oh no, I have to compute everything because of the subtraction. So this is negative 1 over negative 3, so that's 1/3, minus, and minus is a plus, and I have 1 over here. So that's a positive number, so altogether is negative. And I have concave down on the first one. Now, does that make sense to have a concave down to the left of 2?
Yep.
Yeah, doesn't that look like concave down? The whole second derivative test in this case is a waste of time, but hey, it's a good practice, exactly. And we warmed up and so on. So now f double prime at 3 is going to be positive, so it's going to be concave up. Let's graph. Key for the graph is large graph. Also remember that one of your points is all the way at y equals 8. So, you know, plan to go up to y equals 12, 13 or something on your y-axis. I'm going to start counting down from 13. Asymptotes. I have a slant asymptote x plus 2. It's a 45-degree line, so it's going to go through the corners of these squares. And then there will be a vertical asymptote at 2. We are going to draw vertical asymptote, red, at 2. Now we have a lot of different points. We have, all the way at top, 0, 0. We have 0, 0 is a max, and then a 4, 8. Okay, 0, 0 is a max, and X and Y intercept. Guys, when I have a max, I draw a little frown. See that? Right there. And then we have a 4, 8, which is here. And since it's a minimum, you put a little smiley through it. I think it's clear which way the graph goes. It has to follow asymptotes, and your min and max helped you with a frown and a smiley. Right? So all you need to do is to follow the lines from this point on, and you have your graph. The next step is Desmos.
Can there be something to the left side?
This side of the graph will extend to infinity on the left.
Okay. And
Which means that if you draw anything over here, it will no longer be a function because you will have two stacked on top of each other. Vertical line test prevents you from having them stacked.
Thank you.
Can you cross a slant asymptote?
No, only horizontal locally. And I'm hoping to run into at least one problem that will show that, but you know, it's hard to guess which one of these would do that. So the graph we are looking for is x squared divided by, x squared divided by x minus 2. Do we all see it? This is 10, 2, 4, 8, 2, 4, 6, 8, 10, 2, 4, 4, 2, 4, 4, 4, 6, 4, 8, minimum, 4, 8. 0, 0, maximum, and right, so you see that we don't know what these graphs look like before we start. Clearly today we have tools like Desmos, right, Mathematica and your graphing calculators to graph these tools quickly, right, to graph these functions quickly. So in some sense this section, you know, honors our ancestors and the way they used to do this before technology, right? And don't think that this ability to graph was there forever. If you take a TI-83 calculator and look in the back, or the year of production is usually 1999. So these graphing utilities that graph these kind of things are, you know, 20 to 30 years old at most. For the whole civilization, right, existence, if you had to graph, you had to wait for calculus and all of these kind of things, right, so you can do this. And then now you can do the graph by, you know, on Desmos, but just 30 years ago, you had to do, every engineer, right, had to do these graphs by hand this way. That's how new this stuff is. I mean, that's how old what we are doing by hand is, and that's how new this thing is, right? So you are completely living in the new. One of the, I don't know which talk, but somewhere in one of the talks, speaker said, introduced to his whatever 5-year-old daughter or whatever a concept of a paper laptop where they bend the paper this way, right? And then they open and it has this bend, and then they draw the screen and draw the keyboard, and that's like a paper laptop, so they can play with it, right? And when he asked his 5-year-old daughter, said, I when I grew up, like, we did not play like this. Why do you think that is? And she said, oh, you had no paper. Like, no. Laptops started in 90s, all right? There were no laptops before 90s, but this is, so your generation is completely different than the generation before, and, yeah. All of this done by hand. Let's do something easier. And then we're going to call it after this example. We're going to do the review and lab and eventually go into the night. F of x equals ln of x squared plus 1. Excellent. It's 5,000 degrees, I love it. It's 5,000 degrees, I love it.
Pizza? Pizza? Dad? Hey!
Now this is how you win the contest.
Where's my treats?
Oh, it's in my house. This is how you do it.
Yeah. Oh yeah, this is all real metal. So where's Beat Saber? I was told that you have Despacito.
I do.
Approximately like what was it? 10 seconds ago you said that.
Yes.
Oh, okay. Are we gonna play it like right now?
Oh no, I don't have video.
Oh, okay. Are you streaming right now?
Yes.
Am I on the stream?
Yes.
Oh, sick. Facebook.
Oh no.
YouTube.
Well, there's no.
Yeah, well.
Draw something on the.
I have to go here now. His candy, yeah.
Oh, I like candy.
Oh,
Keep doing
I'll take a car. I'll take a car.
Keep doing the derivatives.
Can I get candy?
a priest giving a kid candy? Yeah, come to my office. That's what it's
Candy. Wow, what a treat.
Come to his office.
Come to my office.
He's about to ask for a confession.
Come to the rectory, little boy.
This office so dark.
Jesus, about to touch. This music is lovely.
Just leave the room, come back in. Trick or treat. Trick or treat. Yeah. What do you know? Everything.
Me too.
Send back up. What did you find the X-Intercept?
Yeah, we're just like lost in the.
I don't think there is an X-Intercept.
In a 0-0.
Yo, what is?
It's like that.
No,
That's the derivative.
How do I receive the blessing?
no,
What happened in your office wasn't the blessing?
What?
What?
This
Oh,
way,
you got
when
candy.
when Discord.
I got candy. That's the blessing.
Cat candy?
That's what they all say.
Priestess.
Priests.
Okay.
Thank
Fast.
That's a picture. Oh yes.
Was this the? I'm pretty sure this is not the first time giving candy to kids.
Wait a minute. Which of you is
Don't worry about it.
What?
I was like, which of you are
Wait, who is what?
Who's who in the Discord?
No, we're not gonna do that.
We don't do that.
Who are you? Are you the Great Gambino?
No.
What?
Who's the Great Gambino?
Yeah, who's the Great Gambino?
That's a secret.
It's a secret to everybody.
No.
Anyone can be the Great Gambino.
Yeah.
Alright, well, I should take my leave now.
You should.
Goodbye.
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 I got the English.
Finally away from your cigarette.
I've never studied this guy.
Oh, but the school is on, so it can be
I mean, logged in 24 hours of sleep already in the past 2 days.
Do you log, bro?
Oh.
Yeah. It only works for polynomials.
Okay. So that's not
Domain.
All real numbers?
All real numbers. Excellent. From negative infinity to positive infinity, because the quantity x squared plus 1 cannot be made negative or 0. Any value that you pick for x, once you square it, it becomes positive. And then when you add 1, it remains positive. So the lowest value you can get is ln of 1, and ln of 1 is 0. So this function is always above x-axis, we know that much, and it can take any real number for x. Number 2. X-intercept is going to be when we set ln of x squared plus 1 equal to 0 and solve this. In order for it, you can e both sides. You will get x squared plus 1 equals to 1, and then x squared equal to 0. X equal to 0. So we have 0, 0, which would be our x-intercept and y-intercept at the same time. Anytime you get 0, 0, it's always at the same time x and y-intercept. Number 3. Number 3 is going to be asymptotes. Now, usually, ln has a vertical asymptote at 0, but this time it's losing that asymptote because the quantity in parentheses can never be 0. So there are no vertical asymptotes in this case because just no vertical asymptote, right? Horizontal asymptote is dealing with the limit x goes to infinity of ln of x squared plus 1. So for this one, we also have infinity, so no horizontal asymptote, because if you look at the ln graph is always increasing, and you can swap actually limit and ln, and if you take the limit of x squared plus 1 to infinity, you will see that you get infinity, and then ln of infinity is still infinity. So no horizontal asymptote and no slant asymptote, because slant asymptote only occurs when you have polynomial divided by polynomial, when the difference in the powers is 1 in favor of the numerator. Number 4 would be the first derivative, f prime of x. Now that one is beautiful here. And then we have f double prime of x, which we can use the quotient rule, x squared plus 1, x squared plus 1 times 2 minus 2x times 2x, which gives us 2x squared plus 2 minus 4x squared divided by x squared plus 1, everything squared. What happened when I squared over here? So now f double prime of x is going to be equal to 2 minus 2x squared divided by x squared plus 1, everything squared. Good. So I have my first and the second derivative, and we go with the first derivative test, which will give us increase, decrease, min, max. We take the first derivative, 2x over x squared plus 1, set it equal to 0, 2x equal to 0, x equals 0. We already have a point 0, 0 from before, and we will see whether that point is a min or a max once we are done with partition and all of that stuff. We partition the domain, which in this case is from negative infinity to positive infinity. We partition the domain over critical points and asymptotes. We have no asymptotes. We have one critical point at 0. And please remember, if you don't have anything, then entire domain is one partition. You just pick one point. Since we have critical point there, we're just going to have negative 1 and 1. And we will have the f prime of negative 1. That's going to be 2 times negative 1 over something positive, which altogether is negative. decrease. Again, you can punch all of these numbers in a calculator if you don't want to mess with analysis, and you will get a negative value which is less than 0, and you will still have decrease. So whatever. When I plug in 1, I have 2 times 1 divided by a positive number is now positive, goes up, and this is where we, for free, get this point is a minimum. Yes, so it will get a smiley face. We are there now at the 6, and the 6 is second derivative test, which is 2 minus 2x squared divided by x squared plus 1 squared, and that is equal to 0. So now I have 2 minus 2x squared equals 0, 2x squared equals to 2, x squared equals to 1, x equals plus minus 1. We have 2 inflection points. I have to find y values for both of them, and then we'll do the partition. So I have ln of 1, negative 1 squared plus 1, which is ln of 2, and y equals f of 1, which is also ln 2. So negative 1 ln 2, positive 1 ln 2. These are the points that we graph on the the graph. Partitions. We have 2 values, negative 1 and 1. And we have negative 2, 0, positive 2. And we do the second derivative test for negative 2. That is going to be 2 minus 2 times negative 2 squared divided by the positive number, because denominator is squared, right? What I get is 2 minus, that's a 4 and 8, divided by a positive. That's negative divided by a positive. We get the negative number, concave down. Second derivative at 0 is 2 minus 2 times 0 divided by a positive. That's a positive divided by a positive, which is a positive, and we have a concave up. Finally, the second derivative at 2 is 2 minus 2 times 2 squared divided by a positive, which is also a negative number. Same calculation like the first one, concave down. So this is one of those problems when you don't have asymptotes, you don't have too many points, you might have to use something else. Well, let's see. Graph. Draw big. I'm going to pick 2 squares to be 1 unit now. Okay, and what do I do next? We know 0, 0 is a minimum. It will get a nice smiley face. we're going to work out ln2 in our calculator to have 0.7. So 1, 0.7, and negative 1, 0.7 is where my inflection points are. What do inflection points do? They change concavity, right? So if I connect these points, I will have something that it's concave up. Because so it's concave up, right? And then to the sides it needs to be concave down, so you will just go like that. Try to make it symmetric. So this is your 1 ln 2, negative 1 ln 2, your 0, 0, and the next step for us is Desmos. I'll bring it back. So let's see. ln, open parenthesis, x squared plus 1. There it is. So now you know mathematical equation for the drawing of a bird, right? On the kid's drawing, right? It's ln, yeah, it's just ln of x squared plus 1. It's great, right? So math is useful. All right, if you missed any of this writing, here it is. It's a skill, you practice it, and eventually you'll get there. We're going to stop here, take a break, and when we come back, we'll do some review for our upcoming exam for derivatives. Chapter 3.